Okay, our assessment readiness. To begin, look at each area below. Is the area equal to the area of one of the faces of the triangular prism? So I guess what I'll do is I'll go side by side. I'll go with this front triangle here. The area of this triangle is base times height, so 6 times 4 divided by 2. So 6 times 4 is 24, divided by 2 is 12. So I guess for for this front part, that front area is 12. I don't see 12 anywhere there. I'll move on. How about the bottom? The bottom here is 6 times 8, which is 48. This back one, that's going to be 12. You know what? I'll undo that there. So the side, this side here, oh boy, this is kind of tough, but the side with this and this here. So this side is 8 times 5, which is 40. So, I see 40. So 40 is right here. So that's a yes. Okay. I'm going to erase other stuff here. So, and I don't see, oh, I do see 48. 48's there too. So there's another one. And 15. Let's see. The backside, well, that's an isosceles triangle, so this backside here is also 40, and 48 and 12, so this is 15 is a no. All right. Consider the percent change. Let's see. Consider the percent change of each of the pair of numbers. Choose true or false. Okay. So for a 50 to 100, let's percent change is a 50% change. So to calculate percent change, I'll remind you, is you have to find the difference. So you subtract the two numbers. I'll take the well, officially it's the absolute value of the difference. So 50 minus 100, but the absolute value of that is 50. So that difference is 50 divided by the original number, and our original number was 50. So the difference divided by the original number is 1, which is equal to 100% change. So that is false. And our next one, 20 to 25. Let's see. I'm going to erase this. So I need the absolute value of that difference. So the absolute value of the difference between 20 and 25, that's just 5, divided by the original number, which is 20, and that simplifies to 1/4, which is 25%. Yes, true. Okay. Next, 80 to 20. Okay, I'm going to do this in my head a little bit. The difference from 80 to 20, if you subtract those, it's 60. 60 divided by 80, right? So when I subtract those two, it's 60. So subtract these, it's 60 divided by the original number 80, which simplifies to, we'll divide them both by 20, right? It's 2. Oops, sorry. So divide this by 20 and you get 3, and divide the other one by 20 and you get 4, and 3/4 is 75%. So that is a true. So false, true, true. Okay, next is our top of an L-shaped desk. Has the dimensions shown? Okay, so this is our L-shaped desk. What volume of the wood is needed to make the top of the desk? Explain how you solve the problem. So I believe it's 1,000. I'll do it in blue. 1,920 square inches. And how do you solve the problem? I first separated the desk into, geez, that was pretty sloppy, wasn't it? Into 2 rectangular prisms. So the first one, and so I'm going to separate them like this. So prism 1 is 58 times 20. So 58 times 20 times 1. So 58 here, 20 here, and 1, that makes it how thick it is. So 20 times 50 times 20 times 1 is equal to 1,000. Oh, that's 58, isn't it? 58 times 20 times 1. And that is 1,160 square inches. Prism 2 is, now if this is 20 and this whole thing's 58, that means this has to be 38, because 58 minus the 20 leaves you with 38. So I'm going to write 38 inches here. So to get the volume of this other one, it's going to be 38 times 20 times 1. So prism 2 is 38 times 20 times 1, which is equal to, I have that worked out here, 760 square inches. So now the total volume is 1,160 plus 760, which is equal to 1,920 square inches. Okay, let's move on to our last question here. It says the interior of a running track has the dimensions shown. Okay. This area will be planted with grass seed. 1 kilogram of grass seed will cover 40 square meters. Will more than 100 kilograms of grass seed be needed to cover the interior of the track? Explain your reasoning. It looks like we need to know how many square meters we're talking about here. So let's get the volume first. I'm going to do that over here. So it looks like what I have is I'm going to make this, oops, I'm going to make this a little bit bigger. So with this, I'm going to have a rectangle and a circle. This is half of a circle, and that's the other half of a circle. So I'm going to call this area of the rectangle plus the area of the circle. One complete circle. So the area of the rectangle is 84 times 73. 84 times 73 is the area of the rectangle. I'll put that in parentheses there. Plus the area of the circle is pi times the radius squared. Now, what they're giving us here is the diameter. That's why I was able to say 84 times 73 is the area of the rectangle. The radius is going to be half of 73. So that means, this part right here, the radius is going to be 36.5, because that's half of 73. I will have this, so I'll put this in parentheses for the area of the circle is 3.14 times 36.5 squared. Okay, so there's that. And I'm ready to give 84 times 73 is 6,132. 6,132. And 3.14, now we have to remember that this to the squared means 36.5 times 36.5. So 3.14 times 36.5 times another 36.5. Okay, and you should make sure you got that in a calculator. That is 4,185. 4,185. Oops. 185. and I add 6,132 to that, and I get a total area of 10,317, and that's square meters. Now, that is our total area. And the amount of seed we're going to need is, because let's bring this back over here. So I have my area, and 1 kilogram, oops, right over here, it says 1 kilogram will cover 40 square meters. So I have to take this number and divide it by 40 to find out how many kilograms I need. So I have 10,317 divided by 40. And that's 200, which is about 258 kilograms. So will more than 100 kilograms has to be needed to cover the track? To answer that, yes. Yes. The total area of the track, okay, is 10,317 square meters. And the amount of grass needed is 258 kilograms. 58 kilograms. And there you go. That's what you got to know for this. I hope this has been helpful. Thanks for watching.